Okay, in this lesson we're taking a look at probabilities using the normal distribution. And the normal distribution is the one continuous probability distribution that we are going to need to be able to compute probabilities using in this course. So what do we want to be able to do here? We want to be able to use the normal distribution to determine the probability of values falling within a certain range. And we want to determine a range of values that captures a certain percentage of the data set. So these are kind of opposite sort of questions. One, we're given some values and we want to figure out the probability associated with these values. In the other one, we are given a range and we want to figure out sort of the percentage that the values that are going to capture that percentage, or the range that will have sort of that probability that the value is going to fall into. So we've studied the normal distribution already in this course. We know that it's a continuous distribution, and we know that it's used a lot because it applies in a lot of different situations. Basically, any situation where something is being measured, usually that can be modeled by the normal distribution. So as I said in previous units, we used the normal distribution to determine the percentage of data values that were above a certain value, below a certain value, between certain values. What we're doing here is we're just taking the same sort of calculation of a percentage of values that lie in a certain range, and we're interpreting it as a probability. So earlier on we did questions like where they asked us to find the percentage of a population that has a height greater than 180 centimeters, to take an example. So we found that 42% of the population had a height greater than 180 centimeters. We can take that number, and rather than thinking of it as a percentage of that we would measure from a population, we can think of it as a probability. And the probability here is that if we pick a random person from this population, the probability of them having a height greater than 180 centimeters is 0.42, or 42%. Okay, so this kind of we're sort of thinking about statistics and probability here, the same sort of calculations, just interpreting them slightly differently. So let's just jump in here and take a look at an example. So we've got this guy, Hank, who sells hot dogs, and it says here that the daily sales of Hank's hot dogs have a mean value of $570.50 and a standard deviation of $26.10. His daily costs are $530. How likely is it that Hank will make a profit? Well, if we want to figure out how likely it is that Hank is going to make a profit here, what we really want to find out is a probability. And we want to find the probability that our continuous random variable x is going to be greater than 530, because if his profits are bigger than his costs, he's going to make a profit. So the situation that we have over here, we can model this by the normal distribution. We've got our mean value here at 572.50, and we've got some value that we're interested in over here. This is our 530, and the area that we want to find is this whole area over here. We want to know, how likely is it that the value of sales on a given day are going to fall into this blue shaded region, this entire region that is greater than 530. So as we did before with the normal distribution, we're going to start by calculating the z-score for the value that we're interested in. So remember that this z-score is, how do we calculate z-scores? Well, we take our x value, we subtract the mean value, and we divide by the standard deviation. So the value we're interested in here is our 530. We're going to subtract the mean value, 572.50, and then we are going to divide this whole thing by the standard deviation that they give us, which is 26.10. We punch this into our calculator and we get a z-score of negative 1.63. So this tells us that our value, 530, is 1.63 standard deviations, and it's negative, so this means that we are below the mean. And that matches up with that diagram that I drew over there on the left hand side. So now we take this z-score and we go to our table of normal distributions, and we look up that z-score. So we look up 1.63, and in the center of the table we figure out what the area is. So area is 0.4484. Okay, and remember this table of normal distributions that you want to use is on the formula sheet that you're either given at the beginning of class or you can download and print off. So now we want to take this area and we want to use it. Remember that this area that we've just figured out here is the area between the value that we're interested in and the mean. So this area right here is the area from 530 to the mean. Now, to get the entire area, we know that the normal distribution is symmetric. So from the mean up to the very end here is going to be half of the distribution. So we know that this entire area over here, this half of it right here, this represents half the area, or 0.5. So our total area is just going to be, that's the blue area, is going to be that area from 530 up to the mean, 4480, plus 0.5, which is going to give us 0.9484. So we can interpret that as a percent, so let's round that up to 95%. So there is a 95% chance that he will make a profit. Okay, so let's look at a similar type of normal distribution question, just slightly more complicated. Part B here, what is the probability of the sales being between $560 and $580? Let's move on to another page here to do this one here. So we want the probability that they're between 560 and 580. Let's just label our diagram here first. So we know that the mean is 572.50, and 560 is going to be over here just below the mean, and then 580 is going to be over here above the mean. So the area that we want is this entire area between these two. So this is going to involve calculating two areas, the area from 560 to the mean and the area from 580 to the mean, and adding them together. So what we're after here is the probability that our continuous random variable x is between 580 and 560. And so we're going to calculate the z-scores for these two numbers that we're interested in. So we're going to do 560 minus, our mean is 572.50, and our standard deviation is 26.10. That's going to give us a z-score of negative 0.48. Okay, and this is standard deviations. This is, again, below the mean. Our other z-score is going to be, we want 580 minus our mean, 572.50, divide by 2.60, sorry, 26.10, and we are going to get 0.29. Again, that's standard deviations, and this is above the mean. All right, we're going to take both of these z-scores and we're going to go to our table and we're going to look up the area. So the area associated with 0.48 is an area of 0.1844. Now, just to remind you, where is this on our diagram? Well, let's do this in red here. So this area here is the area from 560 to the mean. That's this red area right in here. And our other z-score is going to give us an area of, looking up 0.29 in our table, 0.1141. Now, What's that area? Well, it's the area from 580 down to the mean. So that's this area right in here like that. So obviously if we want that total blue area, the area between 560 and 580, we need to add those two areas together. So our total area is going to be 0.1844 plus 0.1141. Adding those together gives us 0.2985. So how likely is it that his sales for a day are between 560 and 580? Rounding this off, we can say that there's a 30% chance. Well, we want chance, not change. Of sales in that range. So in this question, what we did was they gave us a range and they wanted us to find the probability that the value is going to be in this range. Okay. Now, we can also do the opposite thing. We can use the normal distribution to find a range of values that will contain a certain percentage of the data, or a range that we have a certain probability of finding a particular data point in that range. So let's look at an example here. The heights of 16-month-old oak seedlings are normally distributed with a mean of 31.5 centimeters and a standard deviation of 10 centimeters. What is the range of height centered on the mean in which 75% of the seedlings will be found? So the idea here is our mean value is this 31.5 down here. We want to know some value here. We'll call this like the minimum value in our range, and some value up here. We'll call this the maximum value of our range. And in this area here, this in between, we're going to have 75% of our data. Okay. Now, these ranges, like the distance of each of this minimum and this maximum value from the mean, are going to be the same. So this distance here and this distance here are going to be the same number. And we basically want to figure out what that number is, and then we add it to 31.5 to get the max. We subtract it from 31.5 to get the min. Okay? So we kind of have to work backwards in this question. So if we want this whole blue area in here to be 0.75, in each of these regions on either side of that mean, so from the mean up to max, we want half of that 0.75. So in here we're going to have 0.375 or 37.5% of the data. And same thing on the other side here. From the minimum value, this value that we're calling min, up to 31.5, we want the other half of that 0.75 or 0.375. Now we want to kind of work backwards from that value of 0.375. So what we want to do is, let's think about our max value first, and let's figure out what would the z-score for our max value be. Well, we took our 0.75, we divided it by 2 to get our 0.375. So we know that our maximum value is going to have, there's going to be 0.375 or 37.5% of the data from the mean up to our maximum value. So what we do is we go to our normal distribution table and we look in the center, okay, where it tabulates those areas. And we want to find the area closest to 0.375. So if I look in my table, the closest number that I can find is 0.3749. Okay, that's the closest value to 0.375 that I can find. And if I then take that from the middle and I go out to the sides, I find that this corresponds to a z-score of 1.15. Okay? So my maximum value is going to be 1.15 sigma above the mean. Now similarly, our minimum value, so this is just the max. So we'll just say that max is above mean, 1.15 sigma. The minimum value is 1.15 sigma below mean. Okay, so now we can figure out if this 1.15 sigma is a z-score, okay, and we know that z is equal to x minus x bar over sigma, we can rearrange this to figure out what our x value is going to be. So just taking this, we can bring the sigma over to the other side. Z sigma is going to be x minus x bar, or rearranging this for x, the value is going to be z times sigma plus that mean value. So we know what our z-score is. Our z-score is 1.15. Our sigma is our standard deviation, which is 10. Our mean value is 31.5. So the x value that corresponds to this is going to be, let's see, 10 times that plus that, punching this into our calculator, we get 43. So this max value is 43. Actually, I don't have to say max is, I can just say that this is our max. Now, for the minimum value, we know that it's going to be the same distance below the mean. So our minimum value, the x value, is going to be our mean value minus z sigma rather than plus z sigma. So our mean is 31.5. We're just going to subtract off 1.15 times 10 because it's the same z-score, same standard deviation. And working that out, we get 20. So that's our min value. So 75% of seedlings are, let's say, between 20 and 43 centimeters. Now, so that gives us the percentage of the data, or a range that encompasses that percentage of the data. Now, we can think about that number as a probability. Okay, what this means is that if we choose a seedling at random, what we know is that there is a 75% chance not change, but chance that its height is in the range that we calculated in the previous question. Okay. So We can think of this as the percentage of data that it contains, or we can think of this as a probability of finding a given, in this case, seedling with a height that's in that range.